Good afternoon. Welcome to the gritty reality of real-time character physics. My name is Tim Brockenstick. I'm a senior technical manager, product manager for character physics. So primarily cloth and RBANs, and I'll tell you what RBANs mean. But my background has been 5 years at Epic and started in enterprise, technical animation, and then now in product management. So I work with the physics engineers and as a tech artist support, and as an artist advocate for better user tools and workflows. And if you've used some of the tools, you know that we need better workflows. So previously served a long tour of duty in the visual effects industry, rigging animation, cloth, muscles, rigid bodies, flesh, destruction simulations, lots of character simulation. Quick overview of what I'll be talking about. Real-time character simulation can be challenging. Yeah, for 5.0, we released Chaos, which is our new physics simulation system. NvCloth has all new parameters and features that we'll have to learn. There's also been updates to the rigid body system too. Not as much under the hood, more user workflow fixes there. Another challenge as technical artists working on character simulation, we're usually at the bottom of the resource and perf chart, so we're going to hear something like, "You'll get nothing like it." It's something we generally hear. It's usually implied, but we'll hear it too. So with that in mind, we need to really understand the simulation system that we're working with to obtain its maximum potential. It's also a good time to set the facts straight and give a general reset of the information that might be out there in the wild. There's this wrong information on the internet right now, and it's not anyone's fault. It's just that we haven't been as forthcoming with some of that information. So this is going to try to lay a new ground level of just get us all on the same level with Chaos here, and just so we have a benchmark to start from. I call what I'm about to share campfire tales, because a lot of this stuff is not just it's not stuff I've developed on my own. I've watched other technical artists at Epic, talk to engineers and get their feedback and what best workflow practices and stuff like that. So I'm going to try to jam as much information as talk. I got a lot of slides, and it's kind of technical, a little low level. If you haven't set up cloth or rigids, I'm sorry, but there's plenty of stuff on both on ArtStation Hub, and I'll point those out at the end, and we can kind of go over that at the very end. I'll show you where those are. But to be successful with real-time simulation, you have to dig in. There's just no ifs, ands, or buts about it. And it can get pretty gritty when you're in there. Okay, what am I talking about regarding character simulation? Well, the focus is on character cloth and rigid body secondary motion for this. We're just talking about ways to make your character feel more alive, not just the skin character. And who's using Chaos right now? Well, internally at Epic, we've been using it for over a year, easily. Fortnite, Matrix Awakens, our demo, our Echo character featured in the Valley of the Ancient and Slay, and also some high-profile licensees that legal will not allow me to name. So you get these very generic images. And of course, individuals are using Chaos too, and we'll see some nice cinematic cloth simulation from them later on. Excuse me. Topics we'll cover in this talk: NvCloth 5.0, differences from NvCloth, some updates and key concepts, as well as debugging. We'll switch a bit to Chaos RBANs, which are rigid body animation blueprint nodes. So if you see any of our documentations refer to RBANs, that's why. We're just shortening that because it's just a tongue twister to always say. So I'll mention some improvements and common user issues to be aware of, and then we'll go real high level on art directing Chaos Cloth, where I show how cloth and RBANs can be mixed together in various ways, both by using the same rig or by blending anim graph caches. And this is actually a huge subject that we're just going to glance the surface, and I know I need to do more deep dive descriptions of that later on, but that's the hope. Then we'll wrap up with some 5.1 updates for Chaos Cloth and physics. First off, Chaos versus NvCloth, what's new, what's different? So it's a new position-based dynamic system, all new cloth parameters, no relation to NvCloth. I've already seen that on the internet, and people are trying to make connections. There is no connection. So more painted target masks are available. We've done away with a limited collision support per cloth. It's now unlimited. Backstop has been adjusted. Anim drive normalized value to 0 to 1. I love anim drive. It's one of my favorite parameters. It's now the way it should be. There's been a wind update, as well as addition of cloth blueprint nodes, field support, and easier world collisions. So the workflow hasn't changed to maintain backwards compatibility. And that's, good and bad thing, but that was the mandate for 5.0. And there's nothing really, like I mentioned, specific I can show you that doesn't already exist in existing documentations about setting up cloth or setting up RBANs from the get-go. So we're going to go a little bit deeper into some of the grittier, fine-tuned settings and stuff. So it's all in the details, and it's gritty at that. So note, NvCloth is no longer supported from an authoring standpoint. You can import. There is a generic mapping, but it's not supported from an authoring standpoint because it's a completely different system. This is just a slide, a screenshot, visual comparison between NvCloth and ChaosCloth sim parameters. Chaos is organized by properties. Sorry about that. As new parameters come online, they'll be slotted in their respective areas, and Chaos is still under development. There's really no direct relationship between NvCloth and ChaosCloth. So, however, there is a generic mapping, like I mentioned, that will happen when you're updating an old asset to Chaos. But recommend still that it's just going to get you in a, who knows, like a kind of a ballpark. It won't break your sim. But you'll still you'll have more chances to make it look better in Chaos. New paint masks have been added to go along with the standard max distance, backstop mask, and atom drive stiffness targets. In fact, you'll notice that most of the new parameters are now supporting a matching mask target. Also, you'll notice that there's a low and high value for each of those paintable targets. So you painted 0 to 1 mask, verts painted 0, pick up the low, 1, pick up the high, in between is the scalar. And if there's no mask assigned, then just your low value is relevant. It doesn't matter what you put in the high value. Something that frustrated many during NvCloth setup is the limited number of collision objects that could be assigned per cloth. They've listed the collision budgets for each of the implicit collision objects we have. NV had a hard limit of 32 per collisions per cloth. And the interesting thing about that, it was random. So you can open up your skeletal mesh editor. One time it might be your leg that's causing the overage and the limit, and the next time you open up, it would be the arm. So it was really difficult to debug. Again, with Chaos, no limit, it's up to the user. Also, I want to point out the lesser-known support for convex collisions, now available in Chaos. This existed before, but it's been cleaned up to be more usable. You can import static meshes like I've done here. I'm using an external DCC and just using decomposition to create those. You're welcome to do that, but highly recommend using the convex collision support in the physics asset tool. And you have a single convex hull and a multi-convex hull that are able to be generated. So Manny, our new mannequin on the left, is a continuous surface, and our old buddy Owen, he's got hand cuts and leg cuts, so the convex creation doesn't work as well for him. If you're trying to collide with low tolerance body geometry and clothing, you probably want to consider having a continuous, underlying surface for that. It will increase your performance costs over the generic implicit objects. Here's another way to create single and multi-convex collisions. Say you already have an implicit surface, you can right-click and then regenerate bodies set with a setting to, either the single or multi-convex hull. Sorry, this is actually going to regenerate, and then the multi-convex coming up. That's also there. So backstop distance and backstop radius could be a bit tedious to use with NvCloth. I got a slide here that says backstop simplified. I had another slide that was a lot more difficult to understand what was going on, so I, game time decision, I nuked it and stuff, so we're just going with this slide. So this backstop tells the vertex how far it can go against its normal, and it's used as a great way to prevent collisions without having to use collision volumes. So it's just, you could paint your mask and tell it's like, just allow you to kind of go back a certain distance. So the backstop radius represents a giant sphere that that each vertex will collide against. They each have their own, and you want it to be a large value, like almost like 10 times your max distance, so that will create a flattish surface to collide against each one. So what we had in NvCloth was the backstop radius was calculated to the center, and our new implementation is to the edge of the backstop radius. We had it incorrect, so this is a fix that that we've added to Chaos. Long-range attachments, are also known as tethers, are also used in Chaos as they were in NvCloth. So tethers are more of a real-time construct. It's used to compensate for situations when you have a lack of stretch resistance in iteration. So lot of like Fortnite and stuff, they'll have to use the tethers, and because they're running really low iterations, and I'll mention that a couple times in this, but it connects the each point that's simulated to each point that's fixed, and it's building a string between there, or yeah, a spring, and it's like it allows it for a fixed point. So what you have here is we have a geodesic distance now that's it helps calculate it, and it's a little bit slower to set up, but it'll establish the correct position and length of the tethers better, and it's prone to less prone to artifacts. So one thing about tethers is if you see your character and it starts making kind of like a puppet, you know, you might either have either inefficient linking like it shows on the right-hand side, or you just, you know, you can, you know, you just need to figure out what's happening in there. But arms could be a problem sometimes. It used to be more of a problem, but the geodesic distance helps. But it's just it's something to be aware of because it'll cause your sims to look just weird. We've also added updates to drive stiffness. I mentioned this, but this value determines how strongly the simulation matches the input animated shape. So value of 0 means that there will be no matching of the shape in all simulation, and value of 1 means it'll match as closely as possible. So with NvCloth, you can crank these values, and you kind of get there, but in my opinion, it never really worked intuitively. With Chaos, we have a true 0 to 1 normalized implementation. So this is one of my go-to set of parameters and I'll show you why in a little bit. We've added updates to wind. Legacy wind model, and you'll see a toggle for that in the parameters, is not an accurate aerodynamic model and should be avoided, but it is there if you need to use old assets. Being point-based, it doesn't take into account the surface area that gets hit by the wind, but the new wind model is a face-based aerodynamic model. Field blueprint support is also available. Fields are known for their use in destruction and Niagara, and you can build up operators, vectors, noise fields, radial fall-offs, culling fields, whatever, to generate motion for your cloth. You can pretty much build out this graph as far as your blueprint skills would take you. Speaking of blueprints, Chaos Cloth parameters can now be set up in the event graph blueprint using the Chaos Clothing Blueprint Interactor function, and another tongue twister. This means that there's an equivalent blueprint node for every parameter in the cloth editor, and this is pretty important. Another note regarding blueprint support for cloth. It is on a per cloth basis, so you can isolate the effect of your sim meshes. Blueprint settings will override your skeletal mesh cloth parameters, your original cloth setup. These will override those setups. Unless you have that dialed into a 0, then the blueprint will have no effect. So I do have a tutorial on how to set up this graph, and that's on the ArtStation Hub, and I will add that link at the end. I'll show you where that is. And don't forget about cloth blueprint nodes for sequencer blueprint events when creating cinematics. So I use them to vary my cloth simulation settings when using multiple instances of the same character. Like for the Matrix demo, we had one agent character, and I used him 4 times, and then I just varied his cloth settings on the one skeletal mesh. So I didn't have to have 4 different skeletal mesh setups. And it was actually pretty cool to do that, and it's all done through Sequencer. So here's an example of that. So I have a track, an event, and I'm going to set up a trigger here, and then I'm going to key it, and that's important. Then I'm going to right-click, I'm going to go to Properties and do a quick bind. And what I'm going to do is force cloth. This is going to be a teleport and reset. So this is going to be a cloth reset there. You can't see the full pull down there, but it's resetting the cape. And that builds this little node structure here. And then I just run simulate and play. And so the next time you'll see when cloth is simming, so now when it comes back around and you'll see the little point I'm circling right there, when it hits that, it's going to reset the cloth. You'll see like a little clip reset. So you can, it's one way you can do resets in the engine they're easy, or for Sequencer actually. So in this case, I'm actually taking some existing blueprint, cloth blueprint documents or blueprint nodes and dropping them in there. I just to save time. And these are the ones I showed a few frames earlier. And this is going to add there's this one node, it's going to be a gravity effect. And I'm going to overdrive the gravity. and like something like a 4 or something like that. So it's going to make it really slam down. So once it comes back, I'm going to hit simulate again. So we're running, and then once it hits that node, it's a hard slam. And it didn't go back through her body because I do have a backstop set there too. So there's a couple of things that were happening there. There's a reset, the gravity slam, and then the backstop was helping prevent any kind of collisions there too. So I mean, it's there's some pretty cool stuff you can kind of do with Blueprint Cloth in there. So with the updates to Wind, the addition of fields, as well as Blueprint support, we now have 3 ways to use Wind, which we didn't have before. So wind directional source, that's your standard global wind. That's where you place your actor gizmo, and it affects everything in the world. There's no way to opt in or opt out. So that's the one way that's on the left. Then we have in the middle, we have a Blueprint interactor node. So this is a wind per cloth mesh. This is where you can isolate where your cloth is going to be affected by. And the only thing to note here is that there's a world unit conversion that's different from if you have your global wind and you have like a 5 in strength and a 5 in speed or something, you'll need to convert it by 100. So you'll see like I have a 500 there in that wind velocity. So that's just something. Talk to the engineers. We'll see what we can do to kind of make that a little bit more normalized or something. But it's not yet. But I want to make you aware of that. And then we have a third way, fields. And that's a localized effect too. You can use culling fields, radial fall-offs, but it's not a true aerodynamic solution yet. I want this to be an aerodynamic solution, but it's just not there yet. We don't have it in there. But you can do some really cool stuff with it, so don't ever discount it. It's just that it's going to take a little bit more grittiness on your part to actually do the Blueprint work. We also have a fictitious angular scale. So this is for centrifugal force. The values range from 0 to 2. Which is one of our rare nodes that doesn't have a 0 to 1 value. 1 is a full centrifugal force, 2 is an overdriven. This is used, Fortnite uses this, and so they've got that ability to do it. But one thing we just had Friday afternoon, if you're using large world coordinates and see strange behavior when using this value at like a 1, we just fixed a bug, and until that fix propagates, definitely use your fictitious value at a 0 for now. Another update, cloth collisions with world static objects have been simplified. So 2 toggles you need to know about are collide with environment and forced collision update. There's a lot of old UDN questions about cloth and world collisions. We hope this simplifies it. There's some caveats, but it's a lot easier to use than it used to be in NvCloth. So I have the tutorial online about how to set this up, and I'll point that again at the end of the slides. At the bottom of the cloth parameters, we get into the shared simulation configuration, and this is important, iteration count and subdivision count. This will be your primary adjustments in your day-to-day cloth sim work. We'll deal with max iteration in the next slide, but iteration count, solver iterations, like most cloth solvers have. Subdivision count is your solver substeps. Now this subdivision count is 50% more costly than increasing your iterations. So be aware of that, but it also helps with fast-moving cloth collisions. It's almost you can't get away without it because you just need that extra substep kind of in there, subdivision. And then max iteration count is something to be aware of in gameplay. This is kind of unique to that. It's a max number of iterations when your frame rate drops below 60 frames per second. So it's a hitch feedback mechanism. So it'll dynamically increase as your frame rate drops. And so you may have to adjust this value, but it's the main thing to take away from this is it will not make your simulation any faster. The engineer thinks that the 10 might be a little high, you'll have to kind of play with it. But this is more when you get into gameplay and you're seeing hitches in your cloth, this will actually, below 60 hertz, it'll help try to minimize that pain. And then on to key concepts to be aware of with Chaos Cloth. So a few slides, I mentioned the iterations. There is definitely a core relationship between tessellation and iterations. You have to use less tessellation for a leather garment, else you're going to be paying for, you're going to be paying the iteration costs on your edge and bending stiffness. So when designing your cloth assets and clothing, you need to know your material. Low iterations will not reach convergence, and that's kind of like a rendering convergence or something. If you're running like 1 or 2 iterations, that's why the bending stiffness and edge stiffness don't ever there's not really much of an effect. If you crank up your iterations in the 10s, 15s, 100, then you're going to start seeing this. It's like a rendering convergence, and so that needs to happen. And if you don't have those convergence, you might as well just leave those values. Just edge and strength bending stiffness is cranked at 1, and that's just how Fortnite runs theirs too, because they're running such low iterations. So also some parameters in NvCloth had minimal effect. Actually, some of them we weren't hooked up to anything, so that's probably made your life a little bit worse too. The engineer told me about that too. So as I mentioned previously, low iterations will mean that edge and bending stiffness will have that little visual change, but other parameters such as drag and lift can be very sensitive in Chaos Cloth, even at low iterations. So be aware of that. Also, when you're debugging, focus on using the visualization tool menu in the skeletal mesh editor. And I'm culprit too. I will send a movie to the engineer, and it'll be, you send me the visualization, the physical mesh or something. He wants to see that for debugging purposes, not your render mesh. Doesn't matter. This is what you want to see. This is what you want to look at. So most of you probably use this, but if not, I highly recommend using the proxy simulation mesh workflow. Using handmade or simplified geometry to drive a higher resolution render geometry is one way to control your tessellation and iterations. So for offline simulation and visual effects, this is how we did everything. And I see, a lot of game people do it too, but I don't, some people don't know about it. So I do want to make people aware of this. This is how we do it on Fortnite. You could see that we have almost like a triangle mesh being driven by a square mesh, and you're like, well, if you're not worried about the collisions up in here necessarily, you can get away with it. And it'll help when you're making a mesh, you'll have more control over the parameterization too if you do make it square. So don't be in the camp that you have to make something that exactly matches your render mesh. It just depends on your individual needs and of how tight and tolerant your collisions are. So here's the concept behind the proxy workflow. I have a simulation, that's the yellow mesh. That's my custom hand-built simulation mesh. I'm just going to turn on the vertices, or you can just see the polygons there, just to prove that that's what it is. So I'm going to make a cloth asset from that, and then the renderable pops back in, and then I'm going to turn on activate cloth, or the paint cloth. So I select it, and I need to hide the render. So if you see like a Z fighting that's happening right there, that just means it hasn't been assigned yet. You've made a cloth data, but you haven't assigned it yet. So now what I'm going to do is I'm going to assign it to the renderable. So now when I go back to do my cloth paint, you'll see that it's switching, and that's we'll be painting on the actual simulation mesh, but it's going to be driving the renderable. And so I use big words like I call this a big switcheroo, but it's just you're just popping between, you're using a lower res mesh to drive the higher res mesh. So this is also a good time to bring up the proxy deformer if you're not aware of that. This is a black box. You just don't know what's happening underneath the hood, and we had problems with the barocentric coordinates when they were trying to make that attachment between the renderable and the simulation mesh. So work's been done under the hood. It's now exposed somewhat, and so we have use multiple influences, and this allows you to adjust up to 5 weight vertices based on the vert distance of your mesh. And you will need to adjust this value based on the spatial relationship of your vertices, so that value could change, obviously. And then we also have a smooth transition from skin to cloth. This just toggles the gradual transition from the skeletal mesh skinning, controlling the mesh, to the cloth sim, controlling the mesh. So this is used for when you're really, like Fortnite uses this a lot because they have such low vert counts on by their budget, that they need to have this kind of blend between the max distance and when you're painting out your zero weights, your max distance, and your first line of weights that have active weights, they need that this thing helps with that. It does have a hit to the skinning shader GPU, but it's working on Fortnite. So and they have kind of the kings of finding ways of eking out every bit of performance. So this was the effect I was seeing in the UE4 changeover to UE5 when the engineers came to my rescue. Higher resolutions, this is like, probably a couple thousand verts. The proxy binding was getting a stippled look on the left, so using the fall-off radius cleaned up the bind. Now, more work has definitely been done under the hood to prevent this from happening, so you shouldn't see something this egregious, but be aware that that's what the radius fall-off is for. And when developing proxy meshes, quads are not ideal for cloth simulation. Even with a symmetrical edge flow, you may end up with particles of different weights. So the engine will triangulate upon import, but you're relinquishing control of the edge flow when that happens. It might not matter when you're working with high vert count meshes, but on smaller vert count meshes, Fortnite meshes, 200, 250 vert meshes, it's really, they'll definitely go in there and make sure that that edge flow is perfect, and just so they can definitely get it to bend the way they want it to bend. So, excuse me, in general, avoid splinters. And Delaunay remeshing algorithms work the best for any kind of cloth simulation. Most people who've worked with cloth sim know that, so try to use that if you can, but triangles are still fine. So, and since this comes up a lot, I want to mention there really is no way to say I want a leather or a silk preset. This is the same with NvCloth. I do feel it was much harder to get different material looks in NvCloth than in Chaos. You can check out the cloth content example for ideas I use to generate different materials, but I'm always experimenting myself. I mean, I'm using everything on the parameters to kind of to see what, gravity, just any kind of setting I could possibly think of to use. I'm going to try to use it. So, from what I hear from the engineers, it's a variable that makes it a non-trivial problem to solve because we use different mesh tessellations. We're running with different iterations. So, to make something that works for your LODs throughout, all these different resolutions of different iterations, it's not necessarily different iterations in that, but your different resolutions. They say it's a difficult problem to solve, but it's something we're still going to keep fighting on. So meshing parameters post iterations is the immediate solution, and that just is the gritty reality of it. So this is not a chaos specific workflow, but if I wanted to share this because it's definitely burned me. Say you want to update a cloth sim mesh with updated skin weights, you go into Maya and you paint, it's always usually the underarms, and you're painting new weights. You bring it in as the FBX skeleton mesh workflow. Once you re-import it, it won't update. You won't have those new skin weights. That's because once you create a cloth data, it's immutable, and that's bad and it sucks. Sorry, but there is a way around that, and you need to use the LOD transfer. It's a remap parameters toggle for LOD, and it's removing the old clothing data from the mesh, re-importing new skin weights, create a clothing LOD for the new cloth import, and then right-click. The settings are up here. We're recording these, and so I just want to let you know, because this is something that I've never really seen anyone talk about this stuff before. So I just wanted to kind of get it out there and let this is I'm not happy about it. I mentioned that multiple times to the engineers, but we're trying to fix it. When we look at debugging cloth in the editor, one of the most important console variables, or CVARs, will be stat chaos cloth. This will give you your call count, your solver steps, collider counts, and what's happening with the wrap deform, and they're all visualized in your number forms. So it's very important to run that command. And what I also want you to be aware of is if you're working with multiple viewports. You may be seeing lower frame rates when working with huge projects and not know why. If you're working with multiple monitors, with multiple Unreal Editor windows open, those various cloths are still solving. So just be aware, as you can see, if I minimize my skeletal mesh, the chaos cloth count drops to 1, but when I have it maximized, since I have a skeletal mesh simming or the cloth mesh simming in the skeletal, there's 2 cloth meshes running. So that's going to affect your perf on your main editor mode too. So just be aware. Here's an example of more CVARs. You actually need 3 of them to draw the wireframe in the editor. Who wants to type that? ain't nobody got time for that. So we usually, internally, artists create their own unique editor utility widget, and I'll show you that here in a second. So since we do have many console variables in the engine, and everyone works differently. If you've ever been a technical animator, worked with animators and tried to build interfaces for them, don't try it because they're not going to like it. So give the tools to the people to build their own. And that's what we kind of recommend. I saw this through the Fortnite team members building these, and this is pretty cool because now you can work the way you want to work, build your own using the internal tools. So this is a lot of text here, but all we're showing here is that we've also in Chaos exposed not only in the editor, but in the skeletal mesh editor too. So now you have all the visualization tools, the NvCloth editor CVARs now available. So there's a corresponding CVAR for all of those on the right. So what this means, this is a quick movie showing the basic setup of what the skeletal mesh editor graph for the editor utility widget looks like. And it's using the Unreal Motion graphics. Pretty straightforward. It's like editor utilities, editor utility widget is created, and you start building up these relationships and and the buttons. And then here's me just going through a few of the visualization settings in the skeletal mesh editor. I don't like pull-down menus. I mean, so when you have to go, do that to kind of turn on a visualization tool, it kind of gets frustrating. So I do like building out these little tools like this. So again, thanks for Fortnite and Jared and Charles for that. So we're going to switch over here to rigid bodies real quick. Okay, I was looking to see my clock was, but my clock hasn't changed. Okay, moving on to rigid bodies. We use RBANs for belts, bags, ponytails, chains, but don't be afraid to use them for cloth too. I mean, you're just trying to get a cloth look, so you can, it provides nice secondary motion, and in some cases, especially in different LODs, higher LODs, that might be all you need. So don't try to spend all the time on the using cloth that might take up more perf. You can think about other ways of using it too. Things you might not be aware of when we switch from UE4 to UE5. The simulate mode and the physics asset editor and editor use different instances of the same solver, so you would get different results between the two modes you're in, and that's frustrating, obviously. But we fixed that. But I don't want to confuse the issue because there's still an RBAN and a world mode physics, but now the RBAN modes have been consolidated so they play right in the physics editor as well as the editor. So we also have better stability at lower iterations for longer joint chains, and then there's the quality of life issues that Fortnite has been really plugging away on. So the workflow hasn't changed. You should notice some general improvements, but as well a couple of updates. And we're going to go through some best practices here in the coming slides. Here's a list of common RBAN issues and a checklist to use when building your setups. These are considered best practices when setting up your RBANs. So just want to share what internal users and engineers have suggested. These aren't the only answer, but these are the ones that are successful for us. So these are more for reference. I'm going to go even faster through these a little bit. So, but I want them to be recorded so you can follow back with some reference to these. So 2 things to be aware of regarding mass. Mass and inertia should always decrease down the chain. Well, not always, but I'm just saying those are best properties. So our best work practices. So be aware of your center of mass offset too. Depending on the positioning of your rigid body when it was created, you may need to adjust the offset. In the movie here, I'm just kind of dialing it in for effect. You can get different looks, but it's just one of the things to be aware of. If you're using an automatic generation of physics bodies, you might need to either replace it or move it or use the center of mass to kind of get a better effect. More on distributing mass, best practices. The sum of the bodies in the chain should not be more than the parent mass. You can do it, but you're more apt to jitter. Internally, this is the practice the tech animators follow at Epic for the most part. So all of your child, 50, 20, 10, 5, 7, add up to 87. They still don't add up more than the parent, which is 100 mass. That just helps keep it under control. And since jittering can be a problem when setting up your rigid bodies, first thing to do when debugging, turn off gravity. If things are still moving at that point, you got joints fighting with collisions, and that's a bad thing. Small bodies may need inertia, and so we have inertia scale and inertia conditioning. You can add some damping, and then check your collisions between your constraints. The last resort is sub-stepping, but that's highly expensive and it's used in project settings, so just be aware. Those are the some jittering things. More jittering is inertia conditioning. It's similar to inertia tensor scale, but it takes the guesswork out of it. It increases the inertia for long, thin objects, as well as joints outside the shape of the collision body. It's automatic, so it will adjust if bodies are added or removed. Also, for jittering, projection system deals with constraints, and it fixes errors left behind when the iteration count is too low to properly solve constraints. I'm sorry, I'm using another image or the video of it, but this is actually an important point of this for projection. So projection works by checking to see if a constraint limits are exceeded, and then after the solve step, and then it teleports the child to a position that fixes it. But it's like running the solver a second time with the parent dominates setting enable on every joint. But you don't use projections on cross constraint setups when you're building like a series of cubes here, because it won't, since it's doing this after step, you're not going to get good results. Then for very small objects, maybe you're simulating an earring or something that's physically small, check your gravity, check your simulation space. You may need to update your iterations set in your physics profiles. Don't forget those solver settings in the physics animation profiles too, in the lower right-hand corner. That's kind of, I don't want to say it's neglected, but you can set up, that's what's great about RBANs, you can set up different profiles for your different setups. So we're moving fast right now, I think. So let's happen when ridges move fast. So we have, for fast-moving objects, the old way, the old UE4 way, we used component linear acceleration and velocity, as well as linear acceleration clamp. And that's what we usually concentrated most on there. And you're still welcome to use them. However, we do recommend UE5 way is use sim space settings, which handles rotations. This came out of needs on the Fortnite, which had front-end podium spinning where animations would change. A character would spin on 2 frames, and the RBANs would just kind of freak out. So this allows user to add how much world space movement and rotation to add back in. And then you have a world alpha attribute. You can add a percentage of the simulation. Just remember to whichever one you use to turn the other one off, and that's just a matter of setting the values to 0 in the component linear acceleration scale. So when optimizing collisions, reduce the bodies to collide. That's pretty obvious. Just right-click, collision filtering, no collision. But collisions and low iterations are definitely problematic. So boxes are probably the worst about low iterations. And then we also have what is the most expensive and least expensive. Well, box-to-box collisions are the most expensive. The least are capsule-to-capsule. And wanted to say by a long way is Chris, one of the engineers, was very emphatic about that. So the difference between them is pretty compelling. So fairly explanatory slide, just reaffirming the previous one. Spheres have better collision performance, but their use can be rather limited. We'll keep going on here. And as I mentioned earlier, inertia tensor scale. I don't think I've ever seen a rigid setup at Epic without a 1.1 or 1.2 setting, just FYI. So angular limits and motors are most expensive, and angular limits are more expensive than linear limits. Finally, a note about using RBAN nodes. Per the engineers, it's more efficient to break out and isolate your collisions than to create one like Uber physics asset. This is obviously helps with your organization, editing, debugging, customization, and probably your sanity too. But these are all campfire tales and just sharing with you what I've learned from them. All right, now we're going to NvCloth art directing. This is going to be high level, but hopefully it gives you ideas. We want to talk about how we put cloth and RBANs together in use. Say you're developing a character like this, 5K, I have a 5K vert mesh in there, active motion, some wind. I don't have a rig in it. I just hope it resolves correctly. And that's what you're rolling. You make the cloth and roll the dice and hope that it'll work in every situation, which is, I know it's not going to, but I know I'm going to get more new animation. But these are the types of things we need to figure out how, or we need to know how our character will be used. So maybe this character needs some extra rigging. Actually, a slap together needs a lot of rigging, but it may cost you more time in the front end to add these extra bones and skin weights, but it gives you more options later on, and we'll show you. Apart from just adding bones and skinning, let's look at some other ways you can utilize this extra bit of help that we may need. First, I want to point you to the 2019 Unreal Fest talk, Making the Most Out of Animation Blueprints. This features information about dynamic solutions for low LODs and faking dynamics and higher LODs with procedural animation. So it's using our old friend Anim Dynamics there. So it's very low cost, but mobile. We're going to talk about mobile to hero-based characters, so you got to have a solution for the mobile side, and usually that's Anim Dynamics. So can we combine cloth and RBANs for secondary character simulation? Sure. Fortnite's a prime example of that, combining RBANs and cloth simulation in Anim Dynamics. So they use everything in the kitchen sink to control their simulations in the animation blueprint graph. They put skeleton rigs in their characters' cloth to help with poses and fix clipping issues. They use a slew of animation blueprint nodes. They layer procedural motion with RBANs and add cloth on top. And then they develop the event logic to drive it all. And that's the nitty gritty of it. It's the event logic that's driving it all is one of the key components. A quick simple example of this is using a rigged mesh. So this is using a pose asset and our chaos fixed anim drive stiffness. I have it dialed up to 0.3. It's just to just show you, we're effectively trying to hit goal poses or goal weights that we can help, drive our posing at particular times. So instead of a shape system, which we don't have, you might have, you might have those in an offline solver. We need to rely on rigging to handle a lot of these things where instances where we just need that extra little bit of control. We can get it back to its either skin shape or whatever. So you animate the rig and poses, create the logic to drive that pose. So is crouching, is running, is swimming. So if any of those particular things are happening, you're having the pose asset drive that cloth and that pose in to help with that particular need. And the chaos anim drive helps with that now, with the 0 to 1 normalized value. So in the anim graph, it could look something like this. So this is pseudo blueprint code I just kind of threw together, but it possibly shows how anim dynamics, RBANs, and cloth can be used for both art direction and LOD support. So it gives you an example how to build up these layers from a cache standpoint, then creating your logic to blend at the last step. But there's no right answer. It's completely dependent on your specific character needs, but Fortnite uses it very successfully. So here's we'll dig into this movie a bit. This line of nodes can be our initial pose cache using anim dynamics like trail controllers to keep the sim alive for mobile. Then we move on to the second graph, and it's caching RBANs. Maybe we have a control rig at the end of that one too. We'll talk about control rig in a second. And then third is we're caching cloth and using the pose asset there. And this is for your hero cloth simulation in LOD 0. Finally, the last graph, we'll get down to the last graph right there. And it combines all these caches depending on your logic, which I said the logic is the magic. So, if you're crouching, is swimming, you're trying to drive different LODs, whatever. We're blending these caches based on the need to create and control the motion we need. So, like I said, driving logic is the magic. So, of course, we can also combine RBANs and cloth in the same mesh. I put a rig in the collar here, and it's floppy. It's floppy on purpose, but because I wasn't happy about the self-collisions of cloth that might happen in that region with cloth on cloth right there, and self-collisions are expensive. So it's a floppy RBAN to demonstrate the effect. Just the point is just don't feel that if it's a shirt or something, it just has to be cloth. You can combine different RBANs and cloth together, and it's a matter of using the tools at your disposal to get the look you desire. There's no right or wrong that you have to do. It has to be cloth or something. So you try to do it the most efficient and the most performant method possible. So you got to experiment ahead of time, and that should be part of your general character development. Another example of adding rigging to drive an art direct. You may have seen this movie on Twitter and ArtStation, our friend Julio. This is for a fan film he's making of his own stylized design. So Julio put a rig in it. He's using an offline curtain system, animated Maya, and importing the animation and blending between a skin rig and the rest of the simulated mesh. So he mentioned that he stumbled into the solution for the cape, but he stumbled in the right direction because it's the direction we take internally, when using these types of, when creating these types of setups. So here's the full movie without. Thank you, Julio. And he wanted to share with me another animation. I don't think this has been out there yet. So Julio mentioned the need to blend the cloth sim out about 20% back to the rigging in order to follow the pose he was going after on this one. So he's cloth blend in the editor. Can I play this again for you here? Oops, nope, we're going the wrong way. All right. So especially with fast cloth motion, you might have to blend back. He used cloth blend, but anim drive would be the same way. You're just trying to pull it back to your skeletal, and he was using that to help maintain control, which is critical. So this is how we approach it internally. So I do appreciate Julio for sharing those movies. So here's another example. This is a rig and a skirt, but this time a control rig. So a very simple one, just an FK rig, but now I can animate rig poses in sequence or use anim drive stiffness to hit goal poses. So again, another example of using a goal weighting or a goal posing system. We don't have the shapes yet, so rigging is the best resource we have to do that. But I highly suggest learning more about control rig because being able to animate and rig an engine and then do your simulation on it will be a huge game changer for not having to go back and do the DCC dance back and forth. And I've been told that the control rig team says that, oh yeah, Julio's rig of his little neck rig and stuff, that could be done in control rig, but they didn't volunteer to build one for me yet. But they said it could happen. For a good example of how to use control rig, check out the Lyra project in the marketplace. Do a search for control rigs in that project and grab the foot one. There's a mannequin foot plant. It's a good example of getting the event graph variables. Very simple, but you can funnel that into your control rig. I'm definitely, this is going to be what I use in the future too, control rig to drive all my, event-driven cloth. So main takeaways from the new chaos settings and RBAN best practices is being able to art direct cloth-like effects. So plan ahead. Think about how your simulation will be affected if the animation set keeps changing. So how you handle clipping, LODs. Now your character's going to be riding on a horse. How you deal with that. Simulating high-resolution cloth by itself can be tedious, and even though Chaos Cloth has new parameters which helps consider it can't do it all. User intervention is usually required, and that's another gritty reality of it. Build up your layers, like the graph example from mobile to hero, and do you put a rig in it? At least don't be afraid to experiment. Consider using a combo of RBANs and cloth. If it's a big project, it's always tough to retrofit, and we've heard that from multiple licensees, clients. And then simulation proxy meshing is important. So design your characters and build them with your materials in mind and save on your iterations. Finally, utilize the new Unreal tools at your disposal and definitely check out Control Rig. So real-time simulation is a huge balancing act. So I know it's a very high-level overview. Art directing physics is a topic all onto itself, but I'll definitely explore that further with hopefully get some tutorials out there. But you need to pick your battles wisely. And so let's see what's coming up for Chaos. So this is the physics control component. It's an experimental plugin for 5.1. I didn't mention anything about ragdolls at the start since they're not technically RBANs, but there's a reason and I'll get to in a bit. So what we're looking at is this original boring animation on the left and then the new procedural animation on the right. The physics control component is providing the motion for the steering and the changing of the gears. It's all done in Blueprint. So what's happening here is we're switching parent space and world space using targets. We're enabling and disabling various controls, modifying control points dynamically at runtime, and that adds to the procedural motion. It's more fine-grained than the physical animation component, and it's repurposable, and the engineers tell me it's the foundation for all the new things that they'll be building. So when we look at the graph, dig into it, pretty straightforward. So constraint profile to enable disable limits, allowing the ragdoll to sit. We create controllers and body modifiers, and this is a boilerplate and can be reused. That's they talk about the reusability aspect of it. There's functions to split the body regions into arrays. There's a switch to the feet to make them kinematic. We're enabling controls on the limbs to drive toward the target pose. And then there's some world space controls for spine, to tighten the pelvis to the seat, yet allow forwards and backwards motion, head and neck control. It's like overdriving the target of the neck bend up to 15 degrees. And then you have additional controls for steering wheel and the gear stick, including the control point to the hand. And then the gear changing, which is just shifting constraints between the steering wheel and the gear shifter. So then you add some purlin noise and shake, and there you go. So another look. Their legs are locked in this one. The knees are allowed to move slightly. The spine has soft control, pelvis, extra rule space control, and then we have joint limits constraints via constraint profiles. So I go in there and they've exposed some of these values, and I start playing with them. It's pretty fun stuff to play with, and you kind of start doing some crazy things with these guys. So it's fun. But you know what else is fun? Balloons. So cloth pressure force strength is added for 5.1, so it adds a constant pressure force to each triangle of the simulated cloth. The effect can be modulated across the mesh via a painted mask and another mask we're going to be adding, or it's already in there. The pressure force is applied in the normal direction, but you can use a negative value to push it in. In this case, I have a max value painted at 0 at the bottom, no gravity, and the wind's blowing up, and then just using like a 0.37 to allow the balloon to luff. We've also added cloth buckling. Think memory folds for cloth. So it determines how many curves, bend stiffness determines how many curves, buckle ratio determines which curves end up creasing, and buckle stiffness determines how sharp the creases are. Buckle stiffness is a new parameter, and that means a new mask. There's additional self-collision resolution step available through the use self-intersections parameter. So this will try to fix any cloth intersections not handled by collision repulsions. Self-collision is expensive, and that's just the world that we live in of real-time cloth simulation. So be aware of that. This is added to help as much as can, but it's expensive. So just be aware. Finally, cloth caching for 5.1. How this one works, first you load your plugin, then you have actor, chaos, create cast manager, another pull down. Then you set your cast manager to record, and you press play to simulate your cache in the editor. So first time I tried it, let's hear, this is me setting up the very first time. So I had a new level sequence. I have a manager in there, and I simulated. So then I'm changing my mode to play, but then I'm going to drop the chaos cache manager in the level sequence, and then I add a chaos cache, and then I'm going to, I should go back and play. I hit the play. I thought I did, but I did it again. Then I'm just dragging the sequencer. So this is going to be how all of our, this is the same system that destruction, chaos destruction uses, and it'll be the future of all of any kind of character physics. We'll use the same caching system, and it'll be added on and expanded upon in the future. So caching has been asked a lot by obviously our cinematics, and it'll allow us to push the chaos solver into higher directions too. So just a few more slides. I'm almost there, sorry. What is the future of Chaos Cloth and RBANs? Well, for RBANs, let's keep on keeping on. There's no immediate updates planned. Eventually, the physics control component will be integrated, but there's no time frame for that. That was a very new development just about the week before I came here. That's when they decided to switch that from world physics to RBAN physics. So then we'll also get the quality of life improvements from our Fortnite friends. But for cloth, the big thing right now, we're extracting cloth from the skeletal mesh component into a separate cloth component. I apologize, sorry. Eventually, this will mean a new editor, and I'm not going to say anything more about that. More parameters and controls to support the higher resolution simulations. Caching will help with that. Internal projects like MetaHuman and the cinematic use cases will also benefit from those. So Chaos is a long-term. We want to support it from mobile to real-time cache hero sims. And we're trying to build up on a new system, but it is a process, and it takes work, and it comes down to resources and time and stuff. So just realize that I'm out there using the same stuff that you are, and sometimes if you get frustrated, I know exactly where your frustration points too. So just comrades in spirit, right? I mentioned a few times about the various tutorials on the ArtStation Hub. There's a chaos character physics learning path available there. If you haven't really, some of this talk probably been like, oh, this is way too, I don't know what the hell he's talking about. This will kind of give you a start, but I can't really, like I've mentioned, I can't really give you a whole lot more about the basics of setting up that hasn't been done, ad nauseum for many years, because nothing's really changed. But I do have a few of the new things that we've added, and that, just kind of going over some of the 5.0 Echo character, how they set that up. And I'll try to drop more stuff in there when I get time. And last slide, my gritty reality nuts and bolts campfire tales mashup. So lots of data to digest, and but I wanted to brain dump as much. I think I broke a record with 86 slides. I want to set the playing field back to level with chaos, and I hope there's something that you guys can take away from this all. Thanks to engineers and tech artists, and those in the Fortnite team for all their support, and of course, thank you for attending. Thank you.